Try descriptive statistics. And what I concern is of the key ratio column. I concern on this column, right? Key ratio column. This is in the data set of the lecture number 3, the folder lecture 3 on e-learning. You can find out the key ratio, right? Now I will compute. You make a start. I will compute descriptive statistics, right? So you may use the Minitab, you may show you Excel using this one. It was faster, right? It was faster. Okay. I select the data, and then now I know I want to compute the mean, the sample variance, the minimum, the maximum, quartile, the box plot, the dot plot, the Stevenson diagram. We also compute the by empirical rule skewness. Okay, and we also compute the population variance and standard deviation, right? And then, okay. Here, after compute, I have the mean, right? I have the mean, I have the standard deviation, I have the maximum, I have the minimum, right? Rank. This one is the population variance divided by the population size. Empirical rule say if we apply the empirical rule, let's say about 68%, we take one standard deviation, right? But for this data set, it is 81.8%. This one's the rule say at least, right? The reality may be higher. So this one say 95, this is 95.5. Okay. The skewness. This one, we have what? Left skew or right skew? Right skew. Higher or lower than? Higher than, right? And we have the quartile, first quartile, the second quartile, etc. And we have the Stevenson diagram, right? The Stevenson diagram. And we have the box plot. Okay, look at the box plot. What are the value? 40 or 60? 40, see here? 60. What is it? Too high, right? The value is too high. Look at this one. Tell me we have left skew or right skew? Right skew. You see a longer tail on the right side, right? Okay, the box plot also indicate that we have the right skew distribution. Okay, done. Now I will show you the other thing, which is the frequency distribution. I select quantitative frequency distribution. Back to data first. I select frequency distribution. Now I select the data that I have. Okay, and then I select the interval with, let's say 10. Let's say 10, right? Let's say from, and what is the final? Let's say I start with the 5. So I have from 5 to 15, 5 to 15, 15 to 25, right? And then I have the polygon I can give. So I have here the left one, 5, under 15, and I have how many values like that? I have frequency 15, right? I count for 34%. The cumulative, remember the cumulative? Then I have the histogram. Look at the histogram. Tell me when we have the left skew or right skew? Right skew, right? It's consistent with the descriptive statistic that we just computed, right? And then we have the connect the top of the bar together, we have the polygon. And then we have the arcade, right? Now I will show you how to compute the probability, right? And the probability here we can compute the counting rule. Like for instance, how many ways to arrange six students, right? In a table, in a chair like that, in a bench like that, right? How many ways? 700 calculated way, right? This is what we find out. Now, permutation. If we have total 10 students, how many ways we select 4 students and arrange the 4 students in certain order? So we have 5,040 different ways, right? So we have a permutation. If we do not concern about the order, we just select how many ways we select 4 students from 10, then we have 210. Okay, that? So this is the way for us to compute factorial, permutation, and combination. Now I will have you to compute some discrete probability. Discrete probability. Let's say I want to study the binomial. You do a multiple choice test of, let's say, 10 questions. 10 questions. And the probability that you selected question correctly is 0.25, right? 1 over 4, 0.25. Okay? Then, what is the probability that you have 0 correct answer? About 5%, right? And this is the cumulative. 1 correct answer, 2 correct answer, etc. Maximum 10 correct answer. This is PX provide you the probability. And then this is cumulative probability, right? Cumulative probability. Okay, Anna? Now we have another probability. The hypergeometric. Let's say your class we have 30 students. 30 students. And of the 30 students we have 20 female. Right? And then I select 10 students. 10 students. Okay? And this provides you the probability that I have no female, 1 female, 2 female, 3 female, etc. 10 female. Get that? And this is a cumulative. Now the last discrete distribution is the Poisson. So let's say on average you receive 25 phone calls a day, right? On average you receive 25 phone calls a day. What is the probability that the maximum value that you have actually 20 phone calls? So it will provide you the probability that you have 0 phone call, 1 phone call, 2 phone call, etc. until the maximum value of 20 phone calls. This is the probability 0 phone call, etc. Right? So until you have the probability that you have 0 phone call. We come to the continuous probability distribution, right? So we have the normal distribution, the other distribution that we studied. The uniform implies symbol, so it's not provided here. So it's provided two things. Calculate the probability given z. Right? Remember two problems? Given you z, you can compute the probability. So let's say I want to compute z 1.2. What is the probability? Right? Calculate z. So review. So it provides you this value, right? 1.2. 1.2. So the probability for the lower side in this area, this is 0.884, and this area 0.115. Right? So if you want to find out the probability greater than z, you take the right side. If you want to find out the probability less than z, you take the left side. Take the lower side. Get that? Now let's say I want to find out the probability. Let's say z negative 0.5. Negative 0.5. Tell me, this area greater than or higher than 50%? Tell me, if I want to find out z here, negative 0.5. Then tell me, this area higher than or less than 50%?
Less than.
Less than. This one is higher. Let's see. So I put here. Okay. So you see the lower side, the upper side higher. See that? Upper side here, right? The upper side, the lower side. Lower side 0.3, right? Higher side 0.6. Get that? So that is the way that you find out the probability that when you have Z. Now reverse thing. What is the probability now? Assume you don't have Z, but you have X. Assume I collect the data about this class and I have the mean 50 kilograms. So you put here 50 kilograms. And then you have the standard deviation of 1.5 kilograms. Right? So in this case, the system can compute X directly. It's not just Z, right? So what is the probability for Z? 52 kilograms. Get that? So review. You will have also the probability for less than 52 kilograms. The probability for higher than 52 kilograms. Get that? So if you compute X directly, you need to provide the mean of X and the standard deviation. And if you confirm Z, the mean equals 0 and the standard deviation equals to 1. Get that? We can also do the reverse thing. Let's say, what is the value here? So that here we have 20%. Right? We can do the reverse. Reverse that means calculate X given P. Select calculate X given P. So let's say P 0.2. So we review. We have the Z of what? Z 0.84 and X is 51.2624. Okay, that? This is the value, so that the left side will be 20% and the right side. Okay, so this is provide the probability. It helps you to find out the value of X. Okay, now we have to work with the continuous distribution. Okay. So all of the tutorial, they don't have it for the exponential and the uniform. Uniform is quite simple. The exponential we also can apply Excel to do it, right? Most of the time we work with the normal distribution. Okay, any questions for the first? Actually, the first section from the beginning until now are about descriptive statistics, right? After the midterm exam, then next week we will study inferential statistics, right? So any questions? Do you need to help, right?